Hello students, today we are going to start class 8 chemistry. In this session, we are going to discuss chapter 2 physical and chemical changes part 4. In the previous part of this chapter, you have learned about physical and chemical changes. What are physical and chemical changes? A physical change is a temporary change, while a chemical change is permanent. A physical change is reversible, while a chemical change is irreversible. No new substances are formed after a physical change, and new substances are formed after a chemical change. In physical change, the mass of the substance remain unaltered. But in chemical change, the mass of the substance undergoing a chemical change is altered. Can physical and chemical changes occur together? Yes, they can. Just we will take one example of the burning of a candle, which involves a physical as well as a chemical change. The wax under the wick melts. The molten wax flows down and solidifies. These are changes in state and therefore it is a physical change. On the other hand, a part of the molten wax that vaporizes burns to form carbon dioxide and water vapor, and the burning of a wax is a chemical change. So both physical and chemical changes are occurring together. Then physical and chemical change involve energy change. Whenever physical and chemical change will be there, always energy change will be there. So there is a change in energy when a physical or chemical change occurs. Energy, usually in the form of heat, is either taken in or it is absorbed. When it is given out, it is an exothermic change. And when it is absorbed, it is endothermic change. So what is exothermic change? A change during which heat is given out. And energy change take place during a change in state. A change during which heat is taken in is called an endothermic change. Then energy change in a physical change in state. Energy changes take place during a change in state. A solid absorb heat in order to melt, and a liquid absorb heat in order to change into vapor. Thus, they are the endothermic changes. On being cooled, gases and vapors condense and liquid freeze. Heat is given out, so they are the exothermic changes. So just see one example. It is given in this picture. You can see one example is given. In this, what is the activity? Take a little water in a steel or glass bowl. Pour boiling water into a mug. Hold the bowl over the mug. Steam coming out from the mug will condense as it comes in contact with the bowl. After some time, you will find that the water in the bowl has become warmer than before. On being boiled, water changes into water vapor, and the water vapor condenses, transferring heat to the cold water in the bowl. So after some time, we will see that the water which we kept in the bowl, that will also become warm. How it becomes warm? When the water in the cup is boiling, so its vapor is transferring heat to that water which is in the bowl, and that will also become warm. Why an energy change in a change of state? So this happens because the kinetic energy possessed by the molecules of a substance is different in different state. As we know that in solids, the kinetic energy of the particle is minimum. In liquids, it is slightly more, and in gases, it is so much. So it is the lowest in case of solid, higher in the liquid state and the highest in case of the gaseous state. So energy will be absorbed by a solid to melt and a liquid to boil or vaporize. And heat will be evolved by the vapors to condense and a liquid to freeze. Now, many substances evolve heat, whereas some other absorb heat. While dissolving in a solvent, you can, so one activity is given for you. In this, what they have done, they have taken the glass in the hand and pour some water into the glass and stir it and add some spoon of glucose. The glass will become slightly colder. Thus, the dissolution of glucose in water is an exothermic change. This is the example of the endothermic change in which the heat is taken in. So we are holding the glass in the hands, pouring some water into that and putting some glucose, some spoon of glucose into that. And after some time, we will see that the glass will be cooler. So that is the example of the endothermic change. Now, next is why an energy change in this solution. During this solution, the solute particles break up from the main bulk and hide themselves in the intermolecular space of the solvent. This affects the motion and so the kinetic energy of the molecule. The kinetic energy of the particles is dependent on temperature. You know, more the temperature, more will be the kinetic energy. And so a change in kinetic energy will result in the absorption or evolution of heat. Now, energy change in a chemical change. All chemical changes involve a change in energy. So whenever we are burning something, like one picture is there in front of you, in which a burning matchstick is there, and it is producing both heat and light. When we burn anything, then heat and light are emitted. Then next is photosynthesis. As you know, photosynthesis, it's a process in which the green plants make their food in the presence of chlorophyll, sunlight, and carbon dioxide and water are the raw materials. So in photosynthesis, chlorophyll, the green pigment of the leaves, absorbs sunlight and helps the plant to produce glucose and oxygen from water and carbon dioxide. You have learned that the slacking of flame is a highly exothermic reaction. So much heat is evolved when water is added to quicklime. Quicklime formula is CaO and slacking of flame is calcium hydroxide, CaOH whole twice. So whenever the water is added in the quicklime, slack lime will be produced and the heat is also evolved. Why an energy change in a chemical change? A chemical change involves a rearrangement of atoms. The reactant molecules break up and the product molecules are formed. These processes are not only opposite in nature, but involve different amounts of energy too. So in the overall process, there is either a surplus or a deficit of energy. Surplus means the excess of energy, or there will be a deficiency of energy. If there is excess energy, it will be given out. And if there is energy deficiency, then it will be taken in. So there is a change in energy in a chemical change. Now our next topic is energy requirement for the completion of a change. Why the energy is required in the completion of a change. So endothermic change and exothermic change. Endothermic change. A substance essentially requires energy from outside to undergo an endothermic change. An endothermic change continues only till energy is pumped in. One example is given for you. A solid melts or a liquid boils only till it is heated. And the reaction between nitrogen and oxygen forming nitric oxide, it is a highly endothermic reaction, take place only in the presence of electric spark. So the reaction takes place in the sky only when there is lightning. Then exothermic change. Heat is evolved in the exothermic change. So it appears that no energy should be required from outside by the substance undergoing such a change. And actually there are many exothermic changes, especially the exothermic physical change, which do not need energy from outside at any stage of the change. Common example is condensation of vapor or the freezing of a liquid. Then many exothermic reactions do not take place without being initiated by heating, means till then you will not heat it, you will not ignite it, you will not give the spark, the reaction will not take place. Once initiated, exothermic reactions go to completion on their own. So some examples are given. Hydrogen does not react with oxygen when the two are only mixed, but react explosively when the mixture is kindled or sparked. And this is exothermic reaction. Another example, a piece of coal, wood or paper does not burn unless lighted. When we will light it, only then it will start burning. But once the substance start burning, it burns out completely. Then the reaction between iron and sulfur forming iron sulfide is also an exothermic process. Thus, we can conclude that an exothermic reaction, once initiated, continues, and the heat is evolved is more than enough to sustain it.